first off, I thought I would show you what your answer sheet looks like for your final exam. And of course all the answers are here, it's just they have invisible ink up. But this is what your answer sheet looks like. So you have an idea of what types of problems we're going to have. The first area is functions. And functions, there's 5 questions there. Now functions were things like f of x equals, or f of x plus g of x, and those type of problems that fit into that category. So that's where your function pieces go. Rational functions, that's your chapter 7 stuff. So this is the chapter 7 piece. Systems of equations, that was chapter 8. Radicals was chapter 9. Quadratics was chapter 10. And then the last chapter was, of course, exponential and logarithmic functions. So that one's probably the most familiar to you. So there's a total of 30 questions on your final exam. The graph in here, that is one that you had to do the double shading on. So you can note that remember we graphed one line and we shaded that side, and then we graphed another line and shaded that side and found out where the 2 shadings came together. So that's what that graph happens to be and what we're taking a look at. I think that's what that one is. Or no, that one's a parabola. Sorry about that. No, that one is a parabola. So you graph your parabola with your vertex and your other 2 points that you happen to find. So yeah, that's a parabola. It's not the double shaded graph with that one. And so this kind of gives you an idea of what you've got. So again, 30 questions, so it's not a real long exam. Your practice exam itself is, of course, a lot longer than this is. But the reason the practice is longer is because it has about anywhere between 2 to 3 problems connected with all of the areas that you have on here. All right. So there are some problems that are going to be similar to what you have in here with that practice test. So it'll give you a good idea and a good review of what we have happening with that. So that is that piece. Let's arrow off of that. Pause. I'm going to pause it on myself. Okay. I think everybody has their practice final. So let's take a look at what we have in here with that. Now, you have 2 practice finals. You have a paper copy of your practice final, and then also in Hawks there is this exact same one, but it has, these are going to change. Your numbers and stuff will change in there for what you have. And so when you have that type of a problem in what you're working at with these, just realize that this is going to change. But if you go into Hawks, you can go into Hawks and start your practice test as many times as you want in there. It does not mean that it's limited to only getting on once. So you can get on, check it out, see what problems are in there, play around with it for a while, get out of it. Might not get a good score when you do that part, but then when you pull it back up, you can go in, just as you go to review a test, you can go in and pull up the problems that you missed, or pull up the problems that you're thinking that you don't know how to do, and Hawks will walk you through them. So it's really gives you a good review and a good idea of what's in there. So there's this test and the other one that's in there. The online classes, they have chapters 7 and 9 as one section, and then they have 10 and 11 as another section for theirs. So that's how theirs works. But anyway, so let's see what we can do with some of these things. So what would you want to do with that very first one? And again, we got to make sure that we read stuff carefully to figure out what they're asking us to do. And it says find the restricted values of x for the given rational expression. If there are no restricted values, then write no restrictions. Restrictions mean that, what do you guys think of restrictions? That it can't be equal to 0, right? But what can't be? The denominator, yeah. The denominator in this one, we don't care what happens to the numerator, but the denominator cannot be equal to 0. So we need to take that denominator and we need to factor it so I can figure out what two pieces happen to be in there. So if I take this thing and factor it, so that's number 1. If I factor it, I get an x and an x. And what's my two values? A -4 and a +2, yes. So now I want my restrictions, so x minus 4 equals 0 and x plus 2 equals 0. So I add 4 and I find out that x is equal to +4. If I minus 2, x could be equal to a -2. But if I use either one of these for my solutions, I can't end up putting those in there. And we used this when we were looking at restrictions as far as in values that we had with our radicals that had pieces that would end up working. Or we just had this recently in, I think it was like chapter 10. No, it was in chapter 10. No, it was. Yes, chapter 10 was where we had some of these where we had restrictions of stuff that it couldn't be. Okay, so that would be my answer to this first one up here. So x cannot equal 4 and x cannot equal a -2. So the next one, I think you might be fine with that one, correct? And I'm not going to do all of these, so we'll just go through and figure out what ones you've got questions on. There's another one that's restricted. All that one did was reverse what was in the top part. I think Hawks likes to do that once in a while. He didn't give us something brand spanking new in there. Notice this one factors the same as this one. Outside of the 4 and the 2 have opposite signs within that one. So I think we're good there. Then if we make it down to problem 4, problem 4 is perform the indicated operations of multiplication or division on the rational expression and simplify. So what do we have to do with this thing? What do you guys think? Flip who? Yeah, this one needs to get flipped upside down so that I have xy all over x squared plus 11x plus 24 times 2x squared plus x minus 15 all over x. And so I make this look more like a y in here. And so now what would you have to do? Factor it. So this piece on the bottom, so I have x over y, is going to factor an x and an x. Factors a 24, positive 24, and a positive 11 means I have a positive and a positive. Factors of that 24, they're going to give me 11. 8 and 3. Okay. Then I need to go up to the top here and take this thing and factor it. And that doesn't have a single digit out in front, so we might have to do that over here on the side of the paper. So let's take it over here. 2x squared plus x minus 15. And that's where we do that long factoring, first term times second term. Gives me negative 30x squared. But I want it to add to give me a positive 1. Yep. 6x times a, what kind of 5 though? Yep. Negative 5x gives me that. Replace my middle. Group in my 2's. And I can pull out a 2x out of the first one. What's that leave me with? An x, and what's the rest? 3. Plus 3. And then what comes out of that second one? But what kind? Yep. Negative 5 leaves me with x plus 3. And so this whole thing factors to x plus 3 times 2x minus 5. So I have x plus 3 times 2x minus 5. And that's going to all go over top of x. And then all I'm left to do now is to take that and do what to it? Cancel. Cancel anything that's like. So x plus 3's cancel. The x cancels. And so my final answer to this one is y times 2x minus 5 all over x plus 8. And so that would be my answer to it. Okay. Yes, we good? Okay. If we keep going, another multiplication one. So what has to happen to this one? So flip it over. What happens to number 5? Oops, if I get 5 on here. Can't see it if I don't have it on there. Think you can do that one on your own? What do you think? Brings back the laws of exponents in here, because my laws of exponents, m squared and m squared, we can end up canceling those two out. We can end up canceling one n with the n squared, leaving an n. Then numerically, I can put 7 into itself once, and 7 goes into 21, 3. And 2 goes into 2 once, and 2 goes into 8, 4. So my final answer to this one is 3 times 4 is 12. And I have an n after it. And then finally in the bottom, I don't have anything left. So my answer is just simply 12n. We good? Okay. Just simply have 12n in there for that one. Another multiplication. I think you're good. Are we good with that one? Okay. So once again, factor everybody that's in there. Don't have to flip anything because it's multiplication, and then cancel out what you have to cancel out. Is that good? Okay. So if you work on these over the weekend and you run across any of them that we skipped today that are not working out, we'll do them on Monday. Okay? So we'll get an idea of what ones you weren't able to do for those. But on Monday, again, you're expected to have this thing pretty much completed, right? To get you 10 points for it. Okay. What happens with this piece? It's an addition. So it says, perform the indicated operation of addition on the two rational expressions and reduce your answer to lowest terms. Been a while since we did any of these. So number 7 is 7 over x plus 3 plus a negative 2x minus 13 all over x squared plus 7x plus 12. So if I add things, what do I have to have? Common denominator, yes. So I need to find it. I know one piece of it's going to be x plus 3, but I don't know from this of what other thing I will need. So I need to take this piece and factor it. Yes, x plus 3 and x plus 4. So my new LCD is everybody from the first one and what I need from the second one. So what do I still need from the second one? X plus 4. Yep. So I need an x plus 4 for that one. And then I need to build equivalent fractions. So what does 7 end up being multiplied by? So it's got an x plus 3. X plus 4. Plus a negative 2x minus 13. But what does that get multiplied by? Actually, there's a 1 there, but it doesn't change anything in it. So it only gets multiplied by 1. So distribute. So I have 7 times x is 7x. 7 times 4 is plus 28. Plus a negative 2x minus 13 all over x plus 3 and x plus 4. So now I got to combine on the top. 7x and 2x is 5x. Positive 28 and a negative 13 is a positive 15 all over x plus 3 times x plus 4. Am I finished? Are we done?
No.
Why not?
Yep.
Got to pull a 5 out of this first piece. So if I pull a 5 out of there, I'm left with x plus 3 all over x plus 3 times x plus 4, but now I got one more cancellation to do. So that x plus 3 cancels. So my true final answer is 5 all over x plus 4. So make sure that you reduce everything and you work your stuff through. Okay? This is what I would be looking for if you worked out your final exam question. All right? So your final exam question, that's the type of stuff that you would show. All right? I know we did, of course, everything else on Hawks and on computers. Then we get down to our final exam and we're doing it on paper. But again, that shows that you have mastered the stuff that was in Hawks, and so that's why I still leave it as a paper one. Okay, continuing. Good with the next one? Think you can do number 8? Yeah, it's kind of like number 7. And can you do number 9? That's a subtraction. Think we need to do that one? Maybe we better, just so that we get that subtraction taking place in there. So if we do this one, I have to come up with the common denominator. I already have it. That's the nice thing about number 9. And in number 9, I already have my common denominator, so I have x plus 2 over x minus 7 minus 3x plus 4 over x minus 7. When I do this one, my common denominator is x minus 7, but what has to happen to my numerator? I have x plus 2, but when I subtract this piece, I need to take that whole thing and multiply each piece by a -1, because I need to subtract those. So minus 3x minus 4. And so that's what I end up with. So then when I combine them, x minus 3x is negative 2x. Positive 2 and a negative 4 is a negative 2 all over x minus 7. But it looks like I could factor it, but if I factor it, is it going to help me out? Not at all. It won't factor, won't let me do anything in there, so therefore it is the answer that it is. And so I can't end up doing anything different with that one. So that's what its answer is. So that's what number 9 happens to be. Okay, number 10. Number 10, it says simplify completely the complex algebraic expression. So we had complex ones before, and what did we do to them? Flip the bottom, because this big bar that happens to be in here means division. And so I take the top piece, so I take x plus 3 all over 2x. Flip my bottom, so I'm going to have 6x squared all over 5x minus 4. And end up taking that and canceling anything that cancels. Can I cancel anything in there? Yeah. Yes? What can I cancel? Yeah. The 2 and the 6 gives me a 3 and a 1. The x and the x squared leaves me an x. What about this way? Can I do anything there? No. Can't do anything there, so I'm left with 3 times x plus 3 all over 5x minus 4. And I think you can get by leaving it that way, but if we did finally finish it, we would end up with 3x plus 9 all over 5x minus 4. So that would be my
3x times x plus 3, so x.
Oh, yes, thank you. I forgot my x, didn't I? So I have 3x squared times 9x. Thanks. Yep, I forgot my x in there. Yep, because I have an extra x left over in that spot. Okay. Flipping. Let's flip to the next page. Let's see what we get over here. We get some more complex fractions. Now these have a little more work involved in them, so we probably better take a look at what happens with this top one. That top one, number 11, has some work we have to do with it, because I don't have a straight value to flip in here. I have these whole values. So first off, I need to come up with a common denominator in my numerator. So, or a common denominator for the whole thing. I think that's what we did with some of these, or we could do it the other way too. So if we come up with a common denominator for the whole thing, or for just the top one, it would be x. So 2 is over 1. So 1 goes into x once, or x times 2 is 2x. X and x are the same, so I just have a plus 3. My bottom is going to be x squared. So then what happens with this one? 4 is over 1. So 1 goes into x squared times x times 4 is 4x squared. X squared is itself. 1 times 6 is 6. Now I have something that looks like what I just finished on the other side. So now I can take this and take 2x plus 3 all over x, flip my bottom, and come up with what my solution would be. So what would be my solution to this one? Well, the only thing that cancels is the x and the x squared. So that leaves me with x times 2x plus 3 all over 4x squared minus 6. Multiply the x through, so I have 2x squared plus 3x all over 4x squared minus 6. And I can't break that apart any more than what it is. Okay, that makes sense? We good with that one? Okay, good. The next one down here, think you can handle that one? Yes or no? What do you think? 12 is okay or not okay? 12 good? Okay. We'll leave it, and then again, if you can't do it, we'll take a peek at it on Monday for one that we'll go back through. Okay, 13 is x over 2 plus x minus 1 over 5 equals a negative 2. Now, for this one, I need a common denominator between all of these pieces that I have in order to remove them. Because of the equals in here, these are the rationals that we have equals, because now they're an equation instead of an expression. And if I come up with a common denominator, what's my common denominator going to be? 10. And I take this whole thing and times every piece by 10. The 2 and the 10 will cancel to a 5 times x, it's 5x. The 5 and the 10 cancel to a 2 times x minus 1 on the top. And the last one is going to be a negative 2 times 10. So then what happens with this? So now I got to finish it. So I got 5x. 2 times x is 2x. 2 times negative 1 is a negative 2. And negative 2 times 10 is a negative 20. 5x and 2x is 7x minus 2. Add 2. Get 7x is equal to 20, negative 20, and a positive 2 is a negative 18. Finally, divide by 7 and find x is equal to negative 18 over 7. So that would be the solution that makes this whole thing work and comes out correctly. Okay? Not bad on that one. Hopefully you're remembering these, how to do what we had to do. So 13, if you were doing this on your exam, this is what you put on your exam. All right? Your exam will not have the separate parts that Hawks gives you. All right? It will not have these step 1 and step 2. Step 1 was stating whether there's any restricted values. Do I have any restrictions? I don't, because I have no x's in the bottom. Okay, so there's no restrictions for this one. And then step 2 was solve the equation and simplify your answer. Write your solution is either in integer or a simplified fraction. If the equation has no solution, write no solution. And so that's what we did. We came up with our answer down here of a negative 18 over 7. But in your exam, it will not ask you for whether your denominator is a restricted value or not. Do you think you can do the next one? Are we okay with 14? 14's, whoops, 14 on here. 14 is similar to the one we just did, so I think you're good there. 15? What do you think? Or should we do 15? 15's got a bit of stuff in it. Yes? No? Do it? Don't do it? Don't do it? Or do it? Need to hear something out of you.
No.
No? Okay. All right. So if you can handle it, go for it. And go from there and see what you can do. 16, your friends. The things you have loved all semester long. Ooh, a story problem. Says the distance that a free-falling object falls is directly proportional to the square of the time it falls before it hits the ground. If an object fell 55 feet in 3 seconds, how far will it have fallen at the end of 9 seconds? Leave your variation constant in fraction form or round to at least 2 decimal places. But this is a directly proportional. Remember those guys? We had directly and directly meant a multiplication. We had inversely, and inversely meant a division. And we also had jointly. And jointly was a combination. And because these are variations, we have good old K. Remember we had K in some of these that we ended up coming up and setting up our equation with? There is one on your exam that has one of these variations in it. So let's see what we can do to set this thing up. The distance that a free-falling object falls, so the falling of this free-falling object is directly proportional, so that means it's going to be K times something to the square of the time it falls, so of T squared. Everybody get that out of that? We okay? Okay. Before it hits the ground. So if an object fell 55 feet, so 55 feet is my falling, K is my constant value that I need to find in 3 seconds. So I got to square my 3. How far will it have? How far will it have fallen by the end of 9 seconds? So I have to solve for K. So 55 equals K times 9. Divide by 9. So I find out that K is equal to 55 over 9. So then I got to go back and use my original equation, this one, and put 55 in for K and put 9 in for my seconds and find out how far it has fallen. So 55 over 9 times 9 squared. So F is going to be equal to 55 ninths times 81. Well, 81 and 9 cancel nicely. So after 9 seconds, this thing will have fallen 55 times 9. And what does that equal out there? You guys got your calculators, I think. What's 55 times 9? 495. Okay. Yep, so F is equal to 495. But again, you got to do it in your 2 parts with this one. So if we recap what we did, we looked for directly proportional, or you will look for inversely, or you'll look for jointly at those situations. Then follow that up with whatever it tells you to do to the things after it. The thing before it, of course, means your equals in there, and so you have to be careful with those. So let's flip the page, and I think we got another couple of these at the top of the next page as well. See, this was number 16, so I should put that in my notes. And then let's take a look at 17. So number 17, trying to keep my notes here together of what we did with these. So 17, it says y varies directly. So once again, we have a directly. as the square root of x. So y is a negative 39 equals k times the square root of x and so first we got to find our k, and then we got to put this back in. It says find y if x equals this, and round off your answers to the nearest hundredth. So if I plug this on my calculator, I have a negative 39 is 441, a perfect square. Yes? And what is it? 21. Okay, so I divide by 21, and I find out that k is equal to a negative 39 over 21. To find my new value of y, I will put negative 39 over 21 in for my k times the square root of this big number, 194481. And what happens to that? So what's the square root of this thing? 141, you said? Oh, 441. Okay. Negative 39 over 21 times 441. Well, we know 21 goes into 441 21 times. So y is going to be equal to a negative 39 times 21? Yep. So that is what my new y happens to be. Okay. Do you think you can do the next one? 18 on your own? Inversely means to divide, so you're going to have this one simply going to be y equals k divided by x squared. And so you plug your values in. So I think we're going to leave that one for you to do. So I think you can. Okay, that was chapter 7. So anything in chapter 7 that we still questioning on that? Pretty much straightforward stuff. It's just kind of going back and looking at stuff. Another way to study for this is to go back into your Hawk stuff, pull up your chapter 7, go in and to your review for chapter 7 and pull up that review piece. And that review piece will have all this stuff in it too. And so then you can do it that way too. And do your review maybe as a practice, not as a certify, because then you can go through and click on the ones that you need to work with. So that's another good way of reviewing your chapter 7. So just pull up your reviews and go from there. Okay, chapter 8. In chapter 8 we were dealing with systems of equations in chapter 8. And so if we were given something on this order as your problem, what you would end up doing with that one to solve it, if that's all you had, and that's what you're going to get on your exam, is you're only going to have the problem, not all the extra wording that goes with it, is we would get one of these letters by itself. Whether you got x by itself or whether you get y by itself, substitute it back in for the other number, go through, solve for y, if you solve for x, and then come back and plug that y back into y here and solve and figure out what your x would end up equaling. So let's go through this one and see what first the questions that they ask us. It says determine if the given ordered pair 2, 2 lies on both of the lines in this system of equations by substituting the point into both equations. So will 2, 2 make this thing work? So if I put 2 right here, 2 minus 4 times 2, because 2 also is y, gives me negative 8. So 2 minus a negative 8 is a negative 6. Negative 6 plus 1 is not 0, is it? It's a negative 5. So we would definitely see no. It's not going to work for that solution to this one. So it's not a set for that. The next one is determine if 5/4 comma 5 lies on both lines. So again, we do the exact same thing. So you'd plug in 5/4. So we would have 5/4 minus 5 times 4 is a negative 20 plus 1. Is that going to equal 0? What happens with that one? Yes or no? So if one of these doesn't work, we know that the whole thing doesn't work. This one will work for the one, it won't even work for the one at the bottom here, so that's another no for that one. So that was only asking whether that numbers would end up working for it or not. Number 30, it says write each equation in slope-intercept form and graph each equation. Then indicate whether the system is consistent, inconsistent, or dependent. For the consistent or constant system, enter the solution as the ordered pair. So what do we got going here? So let's see if we can get this to where it looks like something we can end up solving. So if I look at this first piece in here, it's got lots and lots of fractions in it. So negative 10 over 9x plus 1/4 y equals a negative 1/9. So if I multiply everything by common denominator, what's my common denominator going to be? 9. Is it 9?
That's a 1.
Oh, this is a 3. Okay. So 1/3. Yes, so 9 is. So multiply everything by 9, I get a negative 90x plus 3y. No, I don't have. I have a negative 10. Get it together here. Negative 10x. 3y is equal to a negative 1. Move my x over, so I'm going to add 10x. That leaves me with 3y is equal to 10x minus 1. Divide by 3. And I find y is 10/3 x minus 1/3. So, my slope is 10/3. My y, or my intercept, is 1/3 and negative 1/3, and so I would end up finding those. If I take my second equation, which is negative 5 over 3x plus 1/2 y equals a negative 1 over 6. What's its common denominator? Between 3 and 2, and its common denominator is 6. So 3 goes into 6 twice, gives me a negative 10x. 2 goes into 6 3. And 6 goes into 6 once. Move my, what happened? Look at these two. And let's stop right at that point. What about them? What do you notice? They're the same line, right? So they end up being, of course, dependent. So if I add 10x, just to finish it off, I get 3y is equal to 10x minus 1. Divide by 3. And I find y is equal to 10x over 3 minus 1/3. And these two are identical to each other. So we have two lines that are on top of each other. If we graph it with our equations down here, we would end up having it being equal to each other. So in my boxes, I would have a positive 10 over 3, and over here I would have a negative 1 over 3, and the same down here. What was that? Oh, yep, sorry. Over 3, and I would have a negative 1/3 in that part. So how many solutions do I have for this? Do I have just one solution where they cross? Or do I have an infinite number? Well, if they're on top of each other, infinite. So I'd have an infinite number. If I graph it, I'm going to be at 1/3, negative 1/3. And then I'm going to go up 10, keeping that 1/3 in line, and over 3. And so the graph of this line, can't grab my ruler because it's not with me, but I'd end up with a line running through there. And both lines would plot exactly the same, so I'd have two lines on top of each other if I were to graph that and plot it out to see what took place with it. Okay. What do you think on the next one? Next one is number 21. Can you do that one on your own? Same process. Get y by itself. see whether you have two things that cross each other, and then figure out what you have. Are you okay with that one? Okay. And 22, same thing. 22 is similar to that, so you'd end up going and figuring out what you happen to have with that one. Now these are not going to all be infinite solutions in here. They should be different values that you'll come up with, so keep that in mind. If you have two parallel lines to each other, what would I circle for my solution? I'd have a no solution. Yep. And if they are one's running this way and one's crossing, of course that's a one solution, and you figure out where they cross. And that was the first way we did things in systems of equations, is we graphed them to see whether they crossed or whether they didn't cross in there for that. So we did some graphing stuff with that. All right, 23 is our next one. And in 23, it says determine if the given ordered pair of 5, -1, -4 lies on both of the lines in the systems of equation, and substitute the point into both equations. Does it? And I think you're okay there too, aren't you? We just got done doing one of those. So 23 should be good. 24 should be good as well. That's again plugging in to see if that point's going to work. And we did one of those, so you should be good there. And then 25. 25 is Steve and Kevin live 690 miles apart. They start at the same time and travel towards each other. Steve's speed is 6 miles per hour greater than Kevin's. If they meet in 5 hours, find their speeds. So what in the world's got going with this thing? So I have 25. We have Kevin on one end, Steve on one end, and Kevin on the other. And what are they doing? They are, Steve's walking this way, and Kevin's walking that way, and they plan on meeting in the middle, right? They start at the same time, so time for both of these individuals is exactly the same. Steve's speed is 6 miles per hour faster than Kevin's. So Steve walks at a rate plus 6. What does Kevin walk at? What's Kevin's rate? Kevin's rate is just plain old R, right? Because we can't end up coming up with those. And it says they meet in 5 hours. So the full trip of each of those walking is 5 hours. So how can I set up an equation from this? What do I have to do? Set up an equation. I can make this thing work. Is there a way of making it work?
No, let's pull it out.
Let's throw it out. Let's not do it. Let's see what we can do. Okay. Do we know how far they walked? Or how far they drove, or how far they, I guess they're not walking. I don't think I'd want to walk 690 miles. So they must be driving, right? So if we know that their time is 5 hours, I could set up one equation based on just their time, because Steve plus Kevin is working at 5 hours, if that could be my first piece. Steve plus Kevin is working 5 hours. That's how long they happen to walk. And then the other piece of my puzzle would be, how can I come up with this distance piece? Where does that come in at? That comes right in down here, 690 miles. What would be my other piece to this? Do I have another piece?
R plus 6.
But I gotta have my time in there somehow. But if I put my time into this, I can use my, I could probably, but my R's aren't going to go back to my Steve and my Kevin pieces in there. to end up coming up with what my solution would be. So, what would we have to do? But Steve and Kevin do not equal 5 because they both have 5 hours that's involved. So if I put 5 times r plus 6 plus 5 times r, I will get 690 miles because my rate is what's going to end up working out to do that. So we're not going to use systems on this one. We're just going to end up using what we know about what each is doing, because the 5 hours is a constant value. So 5 times r is 5r, 5 times 6 is 30, 5 times r is 5r, equals 690. So put my 5 r's together, gives me 10r plus 30 equals 690 minus 30. So I have 10r is equal to 660 divided by 10. And I find the rate that Kevin is driving is at 66 miles per hour. So that's Kevin's rate. How fast is Steve driving? Steve's driving at 72 miles per hour. So this is Kevin, and this is Steve. So we end up having those working out. It's under systems of equations, but we don't have to work it with systems. We can end up working it without systems of equations to come up with our answer for that one. Okay, so that's 25. 27. Keep going here. Oh, no, 26. Sorry about that. There's 26 in there. How about this one? The length of a rectangle is 9 feet more than the width. If the perimeter is 198 feet, what is the length and the width? Can we do this one with systems? What do we know? Well, we know the length is 9 more than the width, so 9 plus W. So L equals 9 plus W. What do we know about our perimeter? What's the perimeter formula? Yeah, 2L plus 2W. Well, we know our perimeter is 198. We know 2 times L, and we have 2 times W. And so this becomes my second equation, along with my length is equal to 9 plus W. So if I substitute it in, I have 198 is equal to 2 times 9 plus W plus 2W. 2 times 9 is 18. 2 times W is 2W. So I get 198 is equal to 18 plus 4W minus 18 gives me 180 is equal to 4W. We good so far? Basically just solving for W. Divide by 4, and I find that W is equal to, what's W equal to? 45. Okay. All right. So I know my width is 45, but do I know my length? Because I need both answers. So how do I find my length? Yep, because back up here to length. Length is 9 plus 45. So 9 plus 45? It's 54. So there's my two values. That one was easier than probably 25 was. Okay, 27. A postal service charges 44 cents for letters that weigh 1 ounce or less, and 17 cents more for letters that weigh between 1 and 2 ounces. Jeffrey's testing his father's math skills, giving his father $56.05, and asked him to purchase 110 stamps for his stamp collection. Some 44-cent stamps and some 61-cent stamps. How many of each type of stamp did he buy? Order of operations. not order of operations, but in systems of equations. So what do I know? We know how much you paid. It's $56.05. So how do I relate that to the cost of the stamps? Or can I relate it to the cost of the stamps? Is there a way of relating it to cost of stamps? Well, we know what each one cost. The first type cost 44 cents. So that is X, we'll say. X is the 1 ounce letters. 17 cents more are the ones that weigh between, so we're going to label that Y. Plus, and there's 61 cents. So that's what our cost does for us. And then there's one other piece to this. What else do I know about my stamps that he bought? Anything else? Yeah, there's 110 stamps. So that means, because there's 110 stamps, that means he bought so many X's plus so many Y's. And then that becomes my equation for this one of 27. And so to solve it, I'd probably get Y by itself, maybe, minus X. And I get 110 minus X is equal to Y. Substitute that in where Y happens to be. And I'm going to get rid of my decimals because I just don't want to have to work with them. So if I multiply all my decimals by 100, I will remove those. And then plug it in, put my value for what Y happens to be in there, and end up solving it. So 5,605 is equal to 44x. 61 times 110? What does that give you? 61 times 110. 6,000, what was it? Okay. 61 times a negative x, that's the easy one, I can do that one. And put my 44x and my negative 61 together. What's that give me? Give me a negative number. Negative, what was it? 17x. And then move my 6,710 over. And when I do that, what comes out of this piece? So subtract them. I'm going to have 1,105, I think. Is that right? Divide by a negative 17. And find out that the father should purchase how many of the 44-cent stamps? How many? 65. Okay. And then how many does he need to purchase of Y, or the 61-cent stamp? So then take 110 minus 65 from it, and you will find out what Y is. So what's Y going to be? What was it? 45 equals Y. Okay. And that's what you do with 27. Okay. 28. The sum of two numbers is 42, and the sum of the smaller and 4 times the larger is 147. I think you're good with that one, aren't you? Are you good with number 28? Yes or no? Yes? No? Oh. The sum of two numbers. So that means x plus y equals 42. Okay, that's your first equation. The second one says the sum of the smaller, which you got to label one of these smaller, so we'll make x is going to be smaller. And 4 times the larger, so we're going to make y the larger. So x plus 4 times y is going to equal 147. And then from there you would solve your systems of equations. We good to solve it? Yes? Maybe? Hopefully. 29. Admission to a baseball game is $3.50 for general admission and $5 for reserve seats. The receipts were $4,931.50 for 1,268 paid admissions. How many of each ticket were sold? Same kind of situation as the money one we just got done doing in 27. Same type of stuff. You've got general admission is $350, reserved is $5, so I would say $350 G for general plus $5 reserved, or R, and that's the dollar amount, so that's going to be equal to what? What would that one be equal to? Nope. The $4,931.50. The reason it's equal to this one, because that's the dollar amount that they paid for those seats. The other piece is that you just simply have G, the number of general admissions tickets, plus the number of reserved seat tickets is going to equal the number of tickets sold. And then you'd find your answers from there. I think you can do the rest of it, correct? Okay. And we had different methods for doing that. We had substitution, we had have elimination as well to do these. So you had two methods. Of course, graphing, which you would not want to graph that one. That would not be a pretty sight if you graphed it. 30. Charles made a business trip of 286.5 miles. He averaged 61 miles per hour for the first part of the trip and 47 miles per hour on the second part of the trip. If the trip took 5.5 hours, how long did he travel at each rate? So if we set this one up using two separate pieces, we could say the first part of the trip is X, the second part of the trip is Y, and he spent 5.5 hours doing that. Okay? So that would be my amount of time. Now this one's a little different than the first one we did with Steve and Kevin in the boat, because it was a different method to use that one, because you couldn't end up putting them both together because they both traveled 5 hours. This is the total trip took that long. So then if you go by his average speed, 61 miles per hour for the first part, so that means X times 61. The second part, he drove 47 miles per hour, so that's 47Y, and that all is going to equal 286.5 miles per hour. Or not miles. That's how far he traveled with that one. I think you're good on solving that one? Maybe? What do you think? Yeah? Okay. I'll leave it up there for a second. So I think it's still, you see it okay?
Yeah.
Okay. Excuse me. Turning the page. The sum of two integers is 83, and the larger integer is 14 more than 2 times the smaller. Are we good with that one? I'm going to leave it because I think you might be able to figure that one out on your own with that type of a problem. Okay. 32. We did these using our calculators. Remember our strokes to our calculators? On your final exam, again, you will not have all of this piece. You will just be putting in what your answers happen to be. So you remember how to put that in on your graphing calculators? Yes, if you happen to see it. If I bring my sheet of paper down, you might be able to put it on your graphing calculator. Okay, what were our steps? We put it on a graphing calculator. What kind of steps did we go through to put this thing together? Second matrix. All right, we'll put one line in there and then we'll. So I want to go. It's a 3 by 4, so I go second matrix. And we have them set up in here, but I need to go where? Well, first I need to go down to the one I need. So I need to go down to B. If you got your set up, I think everybody has their set up because I think we went through and did that when we did this. Then I need to go where? Over to edit, yep. I guess down here I need to pick the one I need. Okay, so I pick B, and I got a 3 by 4. Now how do I stick stuff in there? Well, I gotta get off of this piece first, and then what do? Then you just put them in. -7, enter, -7, enter, -1, enter, 1, enter. Do the next line, 6, enter, 1, enter, 3, enter, -1, enter. And last, 2, enter, -2, enter, 2, enter, 7, enter. Okay, so I got it in there. Now what? What was that? Oh, well, you gotta do something before we do second quit. What did I tell you guys you had to do before you go to second quit? Make sure it's perfect. Yes, that you put it in right, that you didn't make any mistakes. Because guess what? It solves it regardless of what you put in there. It doesn't care. So we're going to double check it. So to go down, 1, -1, 7. -1, 3, 2. -7, 1, -2. Back to the first part. -7, 6, 2. Perfect. So now go second quit. Now what? Yep. Now where? Over to math. What was that? Up a couple times? Oh, okay. You want to go up a couple times? We got to go up to B. A few more than a couple times, but we got to get to B, right? Because we got to have R, R, E, F. So we got to make sure that we end up solving it. So now what? Hit enter. Second matrix. Then where? Down to B. Hit enter. Close on parenthesis. Hit enter. And there's my lovely answers. Okay. Lovely answers. But what? Now, let's see. What was that? Yeah. This looks kind of funny because if you're really looking it up above here, you should have 1, 0, 0 a number. The middle should be 0, 1, 0 a number. And the bottom should be 0, 0, 1 and a number if you have a solution. But this one doesn't. And so if I go across my whole bottom, I've got 0, 0, 0, 1. And so that means I have no solution. Yeah. No solution for this one. Because again, there is no answer. Yeah, if it would have made all zeros across, then I would have infinite. Yeah. And if you have one solution, that's when your matrix will look like 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 4. When it looks like that, and you have one with zeros and a 1, 0, 1, 0, 2, this means that x is equal to 1, y is equal to 2, and 1 or z is equal to 4. And so that would be your solution to it. But when you have all zeros, so if it came out as 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 0, 0, that's infinite. And when it comes out as 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 0, 1, or some other number down here, that means a no solution. So you have no solution with that one. All right, I think we got what you got to do with matrix, right? So I think you're good with 33. Am I right? You just got to plug it in. But we're going to take a look at 34 though, because 34 is a story problem, and we need to figure out what our matrix is from the story problem. It says, use the systems of equations to solve the following problem. It says a local theater has 3 types of seats in a Broadway play. It has the main floor, it has a balcony, and it has a mezzanine. Oh, we got to come up with something different for the main floor. We're just going to call that one just the floor. We'll put an F in there. And let the mezzanine be M. The main floor tickets are $57. The balcony tickets are $36. And the mezzanine tickets are $27. One particular night, the sales totaled $33,975. I'll move this down so you can see the words. That looks like it's out of focus. Out of focus? I think it is. Let me see here. I did this yesterday, and when my student said, "Oh, I've got a headache," she watched it. Focus. There, that's better. Okay. So what does this mean? If I have $3,975, what type of equation does that come out to be? 57, don't forget your letter, main floor, plus 36 balcony, plus 27 the mezzanine is equal to 33975. Okay, so that's the first equation of my 3 equations I'm going to have. What's the next one? Reading on. There were 369 more main floor tickets sold than balcony and mezzanine tickets combined. So what does that mean? 369 plus the main floor, which is F, is equal to the balcony plus the mezzanine. Good with that part? That look right? Or did I leave something out?
Yeah,
Do I have to minus F? Yeah, I need to get, because this isn't set up right to put into my equation, right? So I need to get B and M over here with F and get 369 on the other side. So I have F minus B minus M equals a negative 369. Because B is going to come over here, making it negative. M is going to come over here, making it negative. And 369 is going to go to the opposite side and make it negative. So here's equation 1, equation 2. Now I need one more equation, so I got to read the rest of it. It says the number of balcony tickets sold is 46 more than 4 times the mezzanine. What in the world does that mean? The number of balcony tickets is means, what's is mean? Is always means E equals, yep. 46 more than 4 times the number of mezzanine. So 46 plus 4 times the mezzanine. So now I gotta get that so I can put it into my calculator to solve it. So I need to move 4M over. So if I minus 4M, what do I have? Well, I have B minus 4M is equal to 46. How many main floor tickets are in this one? None. I still need the 0F out in front of here because I need to put it in my calculator when I solve it. And I think you can solve it from there, correct? Yes? You guys solve it from there? Okay. All right. And so then you just put your information in here, main floor tickets, balcony tickets, and mezzanine tickets. And you need to, of course, label those. And when you do your exam, the same thing has to happen with labeling those. 35. And you put 34 next to this one. Did you guys need a break? Need a break? Okay. Maybe pause this. Okay, 35 is another system. Okay, 35 is another systems of equations problem. And with it, it says the sum of 3 integers is 197. So what does that mean? A plus B plus C equals 197. Perfect. And then it says the sum of the first and the second integer exceed the third by 49. So that means I have A plus B equals the third, but by 49. What does that mean? Does that mean a minus 49 or a plus 49 or a multiplied 49? A plus 49. Yep. And so this is the first equation, but this one I got to modify because I need to move that C over. So it's going to be A plus B minus C equals 49. So that's the second one. And the third equation is the third integer is 19 less than the first. So what does that mean? The third integer, which is which letter? C, is 19 less than the first. So what does that mean? A minus 19. Yep. So I got to fix it so it works into my third equation. So I got a minus A. So I'm going to have a negative A. Do I have any B's in this one? No. So I get a plus 0B plus C is equal to a negative 19. And that's my three equations. And I think from there you can take care of it, right? Plug it into your calculator, do your matrix stuff through it, and go from there to end up solving it. Okay. And then the last piece in here is, of course, graphing with shading. And if we graph these things and we do some shading stuff with them, we end up taking this thing and we need to graph each line. Now, if you're asked to do a graphing with shading, all you will have on your final exam will just be one graph with this piece. So this piece will be in there, and so then what I'd have to do with that part is graph both pieces on it. So if I graph them, what happens? So the first one says graph this equation, so that means I'm down at a negative 9, because my intercept says down 9. My slope says, and this one doesn't even fit on my graph for some crazy reason, and it says go down 6 and over 1, or we can go up 6 and go the opposite way and over 1. Make sure I get 6. And then I got to determine whether my line is dashed or solid. Which one would it be? Solid because? It's got an equals. Then I need to determine what side gets shaded. So what side would I shade? Top part or the bottom part? It has a less than, so that means I would shade side. You can use a test point, put 0, 0 in. So 0 is less than or equal to negative 6 times 0 is 0 is 9. Is this true? 0 is, oops, get where you can see it, is 0 less than a negative 9? Nope. So I do not want to shade where 0, 0 is at, so I want to shade this side of my line. And then in here it has you graph the other line, but we're going to just graph it on top of here because it would be more of what you'd end up doing with your other one. So if I graph the second line, I am up at 3. And then I want to go up 2 and over 1. Is it solid or dashed? Dashed this time. Because there is no equals. And what side of it is going to get shaded. I'm going to extend this line up a little bit farther so that we can see what's taking place there. What side of it gets shaded? So if I plug in my test point is 0, 0 again, and see if it works. 2 times 0 is 0. Y is 0, so 0 is greater than 3. True or false? That's false. So I'm going to shade up above. So my true answer for my shading part is right in here. So it's that shaded part in there. And again, on in your Hawks, you do pieces separately, but in Hawks it will move your values all the way down as you do your problems in there. So it moves it from one to the other, so you get that shaded piece. Okay? So that's my shaded part. And continuing on, I think you're good with 37, right? So 37 is another shading. Just watch this one. What kind of line is x greater than or equal to 2? What kind of line is that? It's a vertical line. A vertical line at 2. And so you're going to have it going down in this direction. And it is solid. And then you decide what side gets shaded. Take this first one, solve it for y, and graph it on there as well. And so you get your shading parts done with that. And then 38, same situation. You're graphing with number 38. And 38, it's got it solved for y's. And again, you do the exact same thing as we just got done doing. I think you're good there? Yes? Hopefully. If you're not, Monday we'll go and take a look at that stuff as well. Okay, on to chapter 9, and that's where we're going to leave off after we get 9 over or through today, which we should be able to get it finished when we do these. Okay, so number 9 or chapter 9 was all of your your radicals equations and solving these square roots and cube roots and so forth. And so as we work through these, the first one in number 39 says that we want to simplify that expression. So we have the square root of 80 x squared y to the 4th. If I simplify it, I need to pull out anything that I can get perfect squares out of. So can I pick anything out of 80?
Yeah.
What?
It's going to be 4 and 5.
It's 4 out front
Yeah.
and leaving a 5 underneath?
Yeah.
Okay. What about x squared?
It goes with 4.
So what comes out though? Just an x. Yep. And what about y to the 4th?
They go outside.
Yep. And what do I pull out? A y, but it's going to be a y squared. Beautiful. Yep. That's what we do to that one. And you are done with number 39. Number 40. 40 has pieces in both spots here. But if we look at each of those pieces, all of its perfect squares, so I can take the top part and break it apart, break the bottom part apart, and what happens to that? What am I left with?
X squared. 9. Y cubed.
Perfect. Yep. So that's what we get on that one. Okay. All right. I'm going to leave 41 for you, because 41 you should be able to. 41 you might want to cancel inside of here first, because you can cancel the 25 out of each of those, and that might help you to break some stuff down with that one. Number 42. 42 says to simplify it, and if I'm going to simplify it, what do I have to do? In 42's case, I have a negative 6 the square root of 5, minus 4 the square root of 5, minus 4 the square root of x. And it's simple.
Square root of 5 minus 4 square root of x.
What am I left with?
Negative.
Negative 10, yeah.
Square root of 5.
Square root of 5
Minus 4. 4.
minus 4 square root of x. Yep. So that just breaks down nice and easy with that one. 45, or 43 I should say. Now 43 has a little more involved in it, because I have 4 the square root of 16z plus 2 the square root of 9z plus 3 the square root of 36z. That one's got 3 pieces I got to break apart, and I got to simplify each of these before I can see if I can combine anything. So what about square root of 16z? What can I pull out? Pull out a who?
That's 2?
Nope. A 4. But because this 4 is out in front, really I have 4 times 4 the square root of z plus 2. What can I pull out of 9z? A 3. And what can I pull out of 36? A 6. Then I got to do my multiplication. So 4 times 4 is 16. Square root of z. Plus 2 times 3, 6. Square root of z. And 3 times 6, 18. Square root of z. And am I done? What do I got to do now?
Well, you just square root of 0.
Add them together, right?
Yep.
And Sam, you had what, 40?
Yeah.
40 square root of z. Okay. So that's our answer, 43. Not bad. Remember those? And I'm going to leave 44 for you. 45 says we need to rationalize our denominator. So what does that mean? Well, no, not really. Finding out what multiplying the denominator and the numerator by. One more time on that, Ashley. No, I can't just get rid of the square root of 3. I got to keep that 5 with it. But what do I need? I need a special name. We called that something. We called it,
Isn't it plus 5?
yes, square root of 3 plus 5, and the square root of 3 plus 5. And that's called its conjugate. And we had its conjugate that if we multiplied by it, what happens with the conjugate is it makes the radical go away, makes the middle term go away, and it also lets me multiply the last piece in there. So on the top, I have to FOIL the top piece. Square root of 7 minus 3 times the square root of 3 plus 5. And in the bottom, square root of 3 times square root of 3 is 3. Negative 5 times a positive 5 is a negative 25. So in the top, square root of 7 times square root of 3 is the square root of 21, because I can't do anything with it. Square root of 7 times 5 is plus 5, the square root of 7. 3 times square root of 3 is plus 3, square root of 3. And negative 3 times positive 5 is a negative 15. And then that's all over. What was that? Oh, yep, thank you. Yes, it is minus. And then 3 minus 25 is a negative 22. But good old Hawks does not like negatives in the denominator. So that means the signs on everything in the top changes. The square root of negative square root of 21 minus 5, the square root of 7, plus 3, the square root of 3, plus 15, all over a positive 22. So that would be my final answer to this one. Good or not good? Conjugates, next one, same kind of thing, but in 46 I would stick my pieces together in there. In 46, I'd put it underneath one radical first off, so let me write it in here. It's 64ab over the square root of 16ab. So what I would do with this is put it under one whole radical and see what I can reduce. 64ab over 16ab. And so what can I cancel out? A and B. Can I do anything with 64 and 16?
Yeah.
Just plain old 4 is what comes out of there? Yep. And then I got the square root of 4, and the square root of 4 is 2. And I'm all done. So I did some simplifying in there to make that come together and make it work out correctly. So simplifying, coming up with stuff that helps me out. But my rule of saying if I have two things that are dividing each other, put them under the same radical, cancel out the pieces that I can. And the last one, number 47 on this page. And 47 says, again, to rationalize the denominator. We good with that one? Yes? Okay. Just be careful when you multiply the negative 6 by your pieces in here. It only multiplies by the numbers in front. So 47 we won't do. We'll leave that one for you guys to work on. And then that brings us up here to 48. And 48 is another rationalizing the denominator. So we good with that? Hopefully. And then down to 49. It says following radical equations, solve the following radical equation, or if there is no solution, write no solution. What makes a no solution? You know what makes a no solution? When you've got a square root? A negative under the square root. Yes, because I can't end up doing that at this point because we didn't have our imaginary numbers yet defined. So what happens with 49? 49 is the square root of a negative 1 minus 6v is equal to the square root of a negative 4v plus 5. Can I do this one? I got some negative things under there. What do you think? Can I do it? You can, because the only thing is if you were asked whether there was any limits on this, you would have to set each piece under here equal to 0. Not equal to 0, but it's got to be greater than 0 or equal to 0, and then you would solve that. But we're not asked to do that in this problem. We're just asked to finish it out. So how do I get rid of these radicals? Square it. So square that side, and I have negative 1 minus 6v is equal to negative 4v plus 5. Then I can solve it. So what comes out of here? So move my 6v over, move my 5 over. Negative 6 is equal to 2v. Divide by 2. And I find that negative 6 divided by 2 is a negative 3. So negative 3 equals v. Now I need to make sure that when I plug a negative 3 back in here, even though I solved it, that it doesn't cause that to become 0. And it will not, because a negative 6 times a negative 3 is positive. Negative 4 times a negative 3 is also going to give you a positive value. So it doesn't, it's the answer. So the answer is simply negative 3 is what v happens to be equal to for that one. Okay, we can do 50. Good with the 50, you think? Yep, square both sides, gets rid of the radical. And can I have that though? 50. No, I can't, because that's saying whatever comes out of here for this answer is going to equal a negative 4. So this one is definitely a no solution because it cannot equal a negative 4. Right? So this can never equal a negative 4 when I take it out of there because it's got to be a positive 4. So how about 51? 51 you can end up squaring both sides and coming up with what your solution would be in 51. So I'm leaving that one. So that's another one you can do on your own. And 52 is find the product of these two. So what happens if I find the product of those two? Well, I got to multiply them. So 52, negative 4 plus 3i times a negative 3 minus 8i. So if I FOIL these, negative 4 times a negative 3, 12. Negative 4 times a negative 8i is a positive 32i. 3 times a negative 3 is a negative 9i. And 3 times a negative 8 is a negative 24. And I times I is I squared. Okay. We done? Not yet, right? Because I need to stuff my i's together. And I need to take care of that thing. And what's I squared equal? Negative 1, yeah. Negative 1. So, if I put this piece together in the middle, I have 12 plus 32 minus 9 gives me 23i. And a negative 1 times a negative 24 is really plus 24. So now I got to add 12 and 24 together and get 36 plus 23i. And that would be what I have for this one. Okay. Good deal. And you can do the next one, because the next one's just like it. And you can do the next one, yes?
Yes.
Okay. Just when you get down to the end, your square root of 5 times square root of 5 really gives you 5. Yep. And that's all of, that brings us to chapter 10. So that's all of those first 3 chapters. So that gets you to those. Now again, if you need to go back and review some more stuff related to these, you can do the practice test that's in the web test. So you got to go to web test like you do a normal test, but there's no password to it. You just click on the final exam practice, click on it, your whole thing will come up. It'll have the same number of questions as this has. So you can concentrate on chapters 7 through 9 or problems 1 through 54, because 1 through 54 should be in the same order as these.
Is that the extra?
That's the extra credit.
10 points in there.
Yep.
Is that packet any points?
Yes, this packet's worth 10 points of regular. That's your homework.
How much is the final exam?
The final itself,
No, that's like 200, but the practice on web test.
that's 10.
10 points extra.
So 20.
Yeah.
That's,
I need that 10 points.
Yeah, yeah. 10 is normal points, okay, and 10 is extra credit points. Just like you have been doing practice tests for all of your tests, that's what the practice final in the web test is like. Okay? And you can get on it and do it as many times as you would like. So I would, next week before Wednesday, I would maybe get on it Tuesday night or Tuesday during the day, pull it up and practice it that way. With that, over the weekend, you can just practice it up and pull up these first parts. But make sure for Monday that you have all of your practice final.